In this video, I'll explain the proof of the constant multiple differentiation rule. The constant multiple rule states that if u is a differentiable function of x and c is a constant, the derivative of cu with respect to x is equal to c multiplied by the derivative of u with respect to x. For example, if y equals f of x is equal to 2x cubed, we can let x cubed equal u, a differentiable function of x, and 2 equals c, a constant. The derivative df dx is equal to the derivative of 2x cubed with respect to x. Using the constant multiple rule, this is equal to 2 multiplied by the derivative of x cubed with respect to x. The derivative of x cubed with respect to x is equal to 3x squared. So we have 2 multiplied by 3x squared, which is equal to 6x squared. We prove this rule by applying the definition of the derivative to f of x is equal to cu. The derivative df dx is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. To explain this highlighted in red is the difference quotient of the function f of x with increment h. It's equal to the average rate of change of the function f of x with respect to x over an interval of length h. It's calculated as the change in the function's value, f of x plus h minus f of x, divided by the length of the interval over which the change occurs, which we refer to as h. The derivative df dx is equal to the limit as h approaches 0 of the difference quotient of the function. Because f of x is equal to cu, and u is a differentiable function of x, the derivative of cu with respect to x is equal to the limit as h approaches 0 of cu of x plus h minus cu of x divided by h. This is equal to the limit as h approaches 0 of c multiplied by u of x plus h minus u of x divided by h. C is a constant, but this value, now highlighted in red, varies as a function of h. The constant multiple limit rule states that the limit of a constant multiplied by a function is equal to the constant multiplied by the limit of the function. So the derivative of cu with respect to x is equal to c multiplied by the limit as h approaches 0 of u of x plus h minus u of x divided by h. From the definition of the derivative, highlighted at the top of the screen, these terms, now highlighted in red, are equal to the derivative of the function u with respect to x. So these terms, now highlighted in red, are equal to c multiplied by du dx. This concludes the proof. To explain the notation we're using, we're referring to the derivative of the function f of x as df dx. Another notation for this derivative is f prime of x, written f apostrophe x. Other notations can be used also. These are just different ways of referring to the same thing, the derivative of the function f of x. If you found this content useful, please subscribe to the channel to receive more content. Thank you very much for watching this video. See you next video.